Hi, my name is Philip. Today I will talk to you about association rule mining. It is an important topic in data mining. It is a traditional topic, very popular, that people talk about in almost all the data mining books. So if you want to try also association rule mining, the things we talk about today, you can check out the SPMF library or software. It is a free open source software you can use on your data or in your research also if you want to do research about association rule mining. Okay. So association rule mining, it is a task to analyze data that was proposed in 1994. It is something very popular, can be used in many fields. So the main goal about this is we want to find some association between some values that appear in your data. So I will give you an example. If we look, for example, at shopping data, we can look at what the people buy, and maybe we find some interesting associations in the data, like the milk. Many people like to buy milk. They also like to buy, I don't know, the cheese or other products. Okay. So if we find these associations, we can then maybe do marketing or sell the products together or other things. Another example, if we look at the data from the hospital, for example, we can find some associations maybe between some symptoms of some people who are sick, okay, for example. So to try to understand something about the disease, for example. So in this video, I will explain what is association rule mining, how it works, and also I will talk about the relationship with item set mining. If you watch my other video, maybe you know already a little bit about item set mining, so I will explain the relationship with this. So first, I want to briefly review item set mining so you know what it is about, because it is better to know about this to explain association rule mining. Okay, so first we review the item set mining. Frequent item set mining is a popular data mining task. The goal, if you have a database, the goal is to find some sets of value, what we call item set. It means a set of values that appear many times in your data. So we say frequent item set. Okay. So in frequent item set mining, here I have one example to explain to you. We have a database with 4 lines, 4 transactions about what some people bought in a store. Okay. So for example, let's say we have a store with a few products. Then transaction 1, some people buy pasta, lemon, bread, orange. Transaction 2, someone else buy pasta, lemon. Transaction 3, another person buy pasta, orange, and cake, and so on. So if we look at this database about shopping, in frequent item set mining, we can try to find the sets of products that the people buy many times together. Okay. So to do frequent item set mining, we need to set a parameter called the minimum support. Here we set to 2, and we find some sets of items, the frequent item set, that are lemon, pasta, orange, cake, lemon, pasta together, lemon, orange, and so on. So these sets are frequent item sets because the people buy them at least twice, at least 2 times. Okay. So the user, if you are the user, you have your data, you need to set a value for the minimum, the threshold here. Let's say you set to 2. Then you want to find the frequent item set. That means the products people buy at least twice in your database. So for example, lemon pasta is a frequent item set because we have lemon pasta, lemon with pasta, and lemon with pasta 3 times. At least 3. Okay. So this is a popular data mining task. If you want to know more, you can watch my other videos also. Okay. So if we want to think about this problem of item set mining, how to solve the problem. We can look at this using a special type of diagrams, a picture like this. Okay. So here in my store, I had the lemon, pasta, bread, orange, and cake. So I use the letter for L, P, B, O, C for these different products. And here on this picture, what I want to show you is all the combinations of products that the people can buy together. So on top we have the empty set, you buy nothing. After that we have only lemon, only pasta, only bread, orange, and only cake. Then the third line, we have LP, lemon pasta, lemon bread, lemon orange, lemon cake, and so on. Then we have 3 items together, 4 items, and if we buy everything at the bottom. Okay, so those are all the combinations if we have 5 products in our store. Now, if we want to see the solution, the problem I just showed you before, okay, we set the minimum support to 2. We want to find what the people buy together many times, at least twice. So here, for the slide I showed you before, this same example always, okay, if we set the parameter, the minimum support to 2, the result is all the yellow sets here, okay. Those are the frequent item set, all the item sets that I have colored in yellow. The white item set, like bread, pasta, bread, and so on, are not frequent. They appear less than 2 times, okay, maybe 1 time or maybe 0 in our database. So in item set mining, basically, we have all these possibilities, and we want to have some good algorithm to find all the yellow item set, the frequent item set, as quickly as possible. So to do this, if you watch my other video, you know already about this, but let me review a little bit. So to do this, there's a very powerful property that we use. It is what we call the a priori property. What does it say? Okay, let me explain to you. So if you have 2 sets of items, X and Y, X is a subset of Y. And you know that X is infrequent, does not appear at least 2 times, for example. Then Y cannot be frequent, okay. So let me show you this with an example, okay. If we know that bread is infrequent because bread appears only once in our database, and now we want to find the item set appear at least twice. So if you know that bread is infrequent, bread is X, all the superset of bread, Y, like bread and lemon, bread and something else, they cannot be frequent, okay. So if bread appear only 1 time, it is impossible that bread and lemon appear more than 1 time. So if bread is infrequent, of course bread and lemon is infrequent, or bread, lemon, orange, and so on, okay. So this is a simple property, but it is used by almost all the frequent item set mining algorithm. So let me show you this with the picture I showed to you just before. Here in this picture, if you know that bread is infrequent, okay, I put in red, that means it's not frequent, then you know that anything else that contains the bread, any other item set, cannot be frequent as well. So that means all these item set in red color here, they cannot be frequent, like pasta bread, bread orange, bread cake, and so on, okay, because they all contain the bread. So using this simple property, you can eliminate a lot of combinations. Okay, so that was the brief introduction about item set mining. Now I will talk to you about the topic for today, association rule mining, and I will explain how it is different and how also it is related to item set mining, so you understand more about this. So I talked to you just before about frequent item set mining. It is useful. It has many applications. For example, you find that some people like to buy the products together, like bread and maybe some beer or something else. So this is useful, but it also has some limitation. Let's say that, for example, in a store, everyone buy the bread, okay? So if everyone buy the bread, maybe you will find that people like to buy bread and beer together, but there's no strong relationship, okay? It is just because everyone buy bread. So of course bread with anything else will appear frequently in your database, even there's no real relationship. So this is a problem. So here, for example, I show you this with another example here. I have the same database that I have shown to you before. So here, if I set the minimum support to 2, I find that pasta and cake is frequent, because pasta, cake appear at least 2 times. But if you look carefully, everyone buy the pasta in this database. So even pasta cake is frequent, we should not conclude that if you buy pasta, you will buy cake. It is just actually only 50% of the people buy pasta will buy cake. So there's a relationship, but it's not very strong. Okay, so this can be misleading when you look only at the frequent item sets. So as a solution, it was proposed to another task called the association rule mining. So instead of finding frequent item set, we want to find association rules. So let me explain to you about this. An association rule will be like a rule like this, okay? It will have this form, X imply Y. So that means, for example, if you buy some sets of product X, you will buy some other products Y. So X and Y are item sets, sets of items or products and so on. And we have one restriction, X and Y must be disjoint. So they cannot contain the same item sets. And X must not be empty and Y should not be empty either. So here I have a few examples of rules. Orange and cake imply pasta. So that means if you buy orange and cake, you are likely to buy pasta. If you buy lemon orange, you are likely to buy pasta, and so on. Okay. So if we want to find the rules like this, we need to decide what is a good rule, a rule that is interesting. So to evaluate the rules, we will use some functions. Okay. First, we will use the support. We'll calculate the support of the rules. So the support of a rule X imply Y will be the number of times that you have X and Y together divided by the size of the database. Okay, how many transactions in your database. So here, let's take some example to explain this clearly. So I have a rule, lemon orange imply pasta. So to calculate the support of the rule, I need to find X and Y together. So lemon orange pasta appear here and here together. So they appear twice, 2 times, okay, divided by the size of the database. There are 4 transactions. So 2 divided by 4, the support of this rule will be 0.5, or 2 out of 4 transactions. I have also here another measure that we will use to decide whether a rule is interesting or not. Okay, We call this the confidence. So how to calculate? The confidence of a rule x imply y is calculated as follows. It is how many times we have x and y together, how many transactions, divided by how many times we have x together, with or without y. Okay. So let me show you an example. If we take the rule lemon orange imply pasta, so how many times we have these items together? It is twice. Okay. Divided by the support of x. That means how many times lemon orange? Lemon orange, lemon orange. So twice. So 2 divided by 2. That means 1. It means 100%. So what does it mean? If you have a confidence of 100%, it means everyone who buy lemon orange will buy the pasta. So it is very, very strong association in your data. Okay. So here I have some more examples for you. Let's look at another rule. Pasta imply lemon. Okay. So pasta imply lemon. Pasta, lemon together appear 1, 2, 3 times. So divided by how many times we have pasta, it is 4. So 3 divided by 4, the confidence of this rule will be 75%. Now if we flip this rule, we do lemon imply pasta. Will it be the same or not? Okay, let's have a look. So lemon pasta together appear 3 times. Okay, lemon pasta together 3 times. Divided by how many times we have lemon? So 3 times. So 3 divided by 3, the confidence will be 1. So 100%. Sorry. So what I want to show you here is that pasta lemon or lemon pasta, if you change the left side or the right side of the rule, you exchange them, the confidence may not be the same. Okay, so this is something important to know. So in association rule mining, now we know enough. I can define the problem. We have as input a transaction database, and we have 2 parameters that the user must set: a minimum support and a minimum confidence. These 2 parameters are values between 0 and 1. And the output, what we want to find, our goal, is to find all the association rules of the form x imply y such that the support is at least the minimum support and the confidence is at least the minimum confidence, greater or equal. So here, for example, I will show you some example. Okay. So here I have an example for you. I have the same database I have shown to you before. So let's say we want to find the association rules. Here I set the minimum support to 0.5 and the minimum confidence to 0.75%. So the result will be all the rules that you see at the bottom. Okay. So this is what we want to find. We have a database. As the user, we can change the parameter, and then we want to find all the rules that have the support at least 0.5. 0.5 means 2. Okay, at least 2. And the confidence at least 75%. Okay. So in this problem, there is always only one solution, but we need to have the good algorithm to find the solution quickly. So why we use the support and confidence in association rule mining? I will explain to you. First, we use the support because with the support we can decide we want to find the patterns that appear many times. So this will help to eliminate some noise or maybe some patterns that are random, that are not really significant in the data. So using the minimum support, we can reduce the number of patterns that we will discover. And also, we can use this to reduce the search and to have some more efficient algorithms. Now, why we use the confidence? Because the confidence will tell you how strong is the relationship between two items. If you buy pasta, how likely it is that you will buy the bread. Okay, we can calculate. So the confidence, it is like the conditional probability. If you have the confidence of x imply y, it is like the probability y given x in the statistics actually. So this is really interesting compared to item set mining. It can help you to find the sets of items that have a strong correlation. Okay. So if we want to find the association rules, how can we do this? So I want to talk about this with you, and then first I will show you a simple approach, and then I will explain the better approach. So the simple approach, what we call the naive approach, it is to create all the association rules. So that means you look at all the possibilities, and then for all these possible rules you calculate the confidence and the support by reading the database, reading again and again, and then you keep only the good rules, the valid rules. Okay. So of course we could do this, but it will be inefficient because the number of possible rules is very large. So I will not do the proof here, but in general, if you have D items, D different items like pasta, orange, bread, and so on, okay, the number of rules will be 3 to the power of D minus 2 to the power of D plus 1. So that means if you have 100 items, there will be 10 to the power of 47 possible rules. Okay. So this is just to show you that the search space, the number of possible rules, can be very, very large. So we don't want to check all the possibilities to find the result, especially if we have a lot of data with many items. So we can make some observation to design a better approach, a better way to solve the problem. So here I have again the same example. We can do a first observation. It is that there are many rules like lemon pasta or pasta lemon. All these two rules here, we can think about them as being derived from the same frequent item set, pasta lemon. So you can think about the frequent item set pasta lemon, and you can think that these two rules actually they come from this item set, okay, because these two rules contain the same items, but we just changed the position of these items. Another example, here we have two other rules that contain the same items, so you could think about them as coming from the same item set, pasta orange. Okay, so let's continue. Now, if we look at this more closely, we can make a second observation. It is that all the rules that contain the same items will have the same support, but maybe not the same confidence. So here, for example, lemon pasta or pasta, lemon, they will have always the same support. This is sure, okay, by the definition. But the confidence might be different. And the other rules here, they have the same items, so the support is the same, but the confidence might be the same or might be not. Okay, it depends. We don't know. Now, we can make also another observation that is very important based on this. If you know that pasta, lemon appear 3 times, then all the rules that have pasta, lemon will be infrequent. Okay, so this is very interesting because there are many rules with pasta, lemon, lemon, pasta, pasta, lemon. If you know pasta, lemon appear 3 times, you don't need to look at these 2 rules. So this is a very interesting relationship between item sets and association rules. So if we want to find the association rules in a good way that is efficient, we will use this observation. Okay. So Agrawal and Srikant, they propose an approach based on this observation. There are 2 steps. First, we will find the frequent item set using the frequent item set mining algorithms. Okay, maybe you know already. And then from these frequent item sets, we will use them to make the rules. So what does it mean? For example, first we find the frequent item set. Pasta, lemon is a frequent. Okay, so because of this, we will make the rule like pasta imply lemon or lemon imply pasta. But other item sets that are not frequent, we don't need to use them to make the rule. So this can save a lot of time. So in these 2 steps, the first one is the most difficult. So actually, most of the researchers have worked on the first step because it is harder. So now let me dive into more details about this. Okay, there are more ideas that we can use to make this even faster to find the rules. So some idea we can observe. Okay, if we have a frequent item set Y, from this frequent item set Y, we could prove that we can make 2 to the power of k minus 2 rules. I will not make the proof, but you could make it if you want. Okay, so that means if you have a set of items with 3 items like lemon, pasta, cake, you could make 2 to the power of 3 minus 2 rules. That means about 6. Okay, so and generally, if you have an item set Y, you could divide this item set into 2 parts to make the rules. So Y, let's say, has some items A, B, C. So you could say A with BC or C with BA and so on. Okay, and then calculate the confidence to keep the good rules. So this is just basic idea. Okay, let me explain more. So here I have an example for you. Okay, let's say I have an item set ABC. From this item set, I can make 6 rules that I show you here. AB implies C, AC implies B, BC implies A, and so on. So basically, the only difference is the position of the items, to the left or to the right of the rules. So now, if I know that this item set is frequent, I can make all these rules. Now, to know if these rules are good or not, I still need to be able to calculate the confidence. So how can I find the confidence? So if you remember, the confidence of a rule like this will be how many times we have ABC divided by how many times we have AB, the left side. So if I want to calculate the confidence, I need to have the support of all these item sets here. Then I will be able to calculate the confidence of all these rules. So this is not a big problem, because if you know that this item set is a frequent ABC, all these item set like A, B, C, AC, all these item set will be frequent also, because they are contained in ABC. Okay, they must be frequent. So if you use the frequent item set mining algorithm, you find ABC is frequent, and you make all these rules. For sure, all these item sets here and here will be frequent. So we have the information to calculate the confidence. So as I said, we know already, because we know already the support of all these item sets, because all the subsets of ABC must be frequent. So, for example, let's say I have an item set like pasta, orange, and cake. It is frequent, let's say, for the support of 2. Then all the subset of pasta, orange, and cake will also be frequent, like pasta orange or pasta cake. It will be here, and so on. Okay, so these are the frequent item set I find in the database, and from this, if I want to make the rule, I just need to check the result to find the support, and I can calculate all the confidence of the rules from these item sets. So now, if you want to do programming, okay, how can you search quickly the support of a set? Let's say I have a lot of frequent item set like this, but more. Maybe I have thousands. How could I search for the support? So here I want to show you a few ideas. First, one solution will be to group the item set by size. So all the item sets that have 2 items, you put them together in a data structure, for example. All the item sets with 3 items, you could put them together. So then, when you want to find the support of an item set, you could search by the size. And also, you could sort the items by some order, like the alphabetical order, and use the binary search and so on. Okay. So here I will not go into details, but this is one way if you want to search quickly for the item sets. Okay. If you have already all the frequent item sets and you want to find quickly what are their support. So there are other ways, but I will not explain today. Okay. So let's continue. Now I want to explain a little bit more about how we can reduce the search. We don't want to look at all the possible association rules. So there is a question here. Could we use the confidence to also reduce the search space? So for the support, we had the a priori property I showed you before. Okay, the special property with the support we can use to eliminate the rules. But what about the confidence? So actually we are lucky, because there's a theorem we can use to eliminate the rules using the confidence. So let me explain this to you. Okay, this one is not so obvious, so I will give you some examples to show it more clearly. So let's say you have a rule. X imply y minus x. So for example, y is ABC. Okay, x is A. So you have a rule like A imply BC. Then if we have a rule like this, that the confidence is too low, it does not have enough confidence, then if you have another rule, x prime imply y minus x prime, and x prime is a subset of x, then you know the other rule also will not satisfy the confidence. Okay, so I know this theorem is not obvious. Okay, if you look at this just like that, it's not clear. It will not tell you, it's not very clear or easy to understand. Okay, so let me explain this with some example. So I will show you an example first, and then I will show you the proof. Okay, so here in the PPT you have the proof about this. Okay, if you have two rules like this and like that, such that x prime is a subset of x, you can prove that the confidence of the second rule will be less than or equal to that of the first rule. But let me show you this with an example. Okay, what does it mean? So if you have x equal a, b, c, d, okay, x is a, b, c, d, you can make many rules like this. So what the property will say, if you have a rule like b, c, d imply a, and this rule has a low confidence, it is less than the minimum confidence, then all these rules I have highlighted here can be eliminated. Okay, so intuitively, if you want to understand this in a simple way, if you take that rule BCDA and you move one item from the left to the right, okay, like CD imply AB, so I take the B, I move the B to the right, okay, so I add BCD, now is a CD, I move the B to the right, then the confidence will be less. Then if I take another item like C here, I move to the right, the other rule will also have a lower confidence. Okay, so this is the idea about this. Okay, for any rules like this, if you take an item on the left, you move to the right, the confidence will be lower or equal. So if we know this rule is not enough, does not have enough confidence, we can eliminate all the rules here. So this is the property that we use in association rule mining to reduce the search space of rules. So if you want to do the programming, here I put the pseudocode for this. Okay, so you could have a look at the original paper also if you want to do programming. It's not so difficult. You could try this. Okay, so now I finish explaining association rule mining. You know already what is association rule mining and how to find the association rules. Now I want to talk to you a little bit more about this. Okay, how can we know the associations are good or not? So I talked to you already about the support and the confidence, but there are also some other measures we can use beside the support and confidence. So I would like to give you a brief overview. So generally, if we have a database, we can find a lot of patterns, a lot of association rules. How can we make sure these patterns are interesting? We can find, for example, the association rules, like if you buy the mouse, you will buy the keyboard, and so on. So we can make sure these rules have the high support, the high confidence. But is it enough or not? Is it really enough to know that these associations are very strong? Maybe, but maybe not. Okay, so let me explain this to you. Here I will take some example to show you some problems about association rule mining. Then I will show you some other measures we can use. So, before I talk to you about the support and the confidence. So, to show you some example, I will use something we call a contingency table. Okay, so let me explain what it is, and then I will show you some problem about this. So here we have a table. Okay, we have A, and A with overline. Okay, so for example, you buy the apple or you don't buy the apple. And B means, for example, you buy the bread, or B overline means you don't buy the bread. So we will look at the combination. Here means you buy apple, you buy bread. Here it means you buy apple, you don't buy the bread. Here it will mean you don't buy apple, you buy the bread. Or you don't buy the bread and you don't buy the apple, and so on. Okay, so we'll make some table like this to try to understand more and see when there are some problems with the support and confidence. Okay, so I will show you some problem. Okay, let's go directly to this. So here I take an example of rule. If you drink the tea, you will drink also the coffee. So if you like drinking tea, you probably also like to drink the coffee. So let's say you have a database and you find this rule, and I tell you that this rule has a support of 15% and the confidence is 75%. So maybe you think this is very strong rules because 75% is really high. Okay, so if you drink the tea, 75% of the people drink tea will also drink the coffee. So maybe we should try to sell the coffee to the people who drink the tea, right? But actually this will be a huge mistake. So let me explain to you why. Okay, let's look at the table here. Here we have 150% drink tea and coffee. People drink the tea and no coffee is 50%. People don't drink tea but drink coffee is 650. And people don't drink tea and don't drink coffee is 150. So here the problem is, okay, if you drink tea, how likely you are to drink coffee? Okay, let's have a look together. So for the tea, there are 200 persons and 150 who drink tea also drink coffee. So 150 divided by 200 means the confidence is 75%. Sorry. Okay, so now let's continue. If you look at the people don't drink tea, are they likely to drink the coffee? So there are 800 people who don't drink the tea, but don't drink the tea but drink coffee, 650. So 650 divided by 800, if you don't drink the tea, there are 80% chance that you will drink the coffee. So actually, if you like the tea, only 75. But if you don't like the tea, you have more chance to drink the coffee. So this rule here is not a good rule, because it will make you think that if you drink tea, you are likely to drink coffee. But if you look at the details of your data, you find out that people don't drink tea are more likely to drink the coffee. Okay, so why do we have this problem with the confidence? It is because of the definition of confidence. We have how many times we drink tea and coffee divided by how many times we drink the tea. But at the bottom here, we don't look how many times people drink the coffee, y, okay. We divide by how many times x, but we don't divide by how many times we have y. So the problem is because of this. So there is a solution to this. You can use other measure beside the confidence. There is another measure called the lift for association rule mining. It is defined as follows. It is, if you have a rule x imply y, it will be how many times you have x and y together divided by how many times you have x and divided by how many times you have y. So divided by the number of people drink tea and the number of people drink the coffee. So this measure called the lift is very popular. And if it is 1, then x and y are independent, means there's no relationship between x and y. And if it is more than 1, the lift, it means x and y have a positive correlation. So that means if it's more than 1, if you drink tea, you are likely to drink coffee. And if it is less than 1, x and y are negatively correlated. So in my example, actually, if you drink tea, the lift will be 0.93, means there's a negative correlation. Drinking tea makes you less likely to drink the coffee. So this is the lift. It is another measure. There are also many others in association rule mining. I will not explain all of them today, okay? So, for example, here I show you some other measures. There are more than 20 measures. I found this in a paper about association rule mining. But the most important measure are maybe the support, the confidence, and the lift. Okay, we also call the interest is the lift. So those are some of the most popular, but there are others. And generally, there is not only one measure that will be good in all the situations. Okay, some measures will be good in some case, and they will not be good in other cases. So maybe you need to try a few measures when you analyze the data to find a good association. And maybe this also depends what kind of data and what you want to do and so on. Okay. So that is all for my video today about association rule mining. I just wanted to give you an overview about this important topic in data mining. Again, if you want to try association rule mining, you can have a look at our software called SPMF. There are also many other algorithms. We can also find association rules with the time and many other things, okay, that I will not explain today because this is just some introduction. Okay, so thank you for watching. See you. Bye.